Okay. Part H. Must there be a time when particle q's velocity is 1 foot per second? Justify your answer. One of the things the College Board loves to do is, again, throw as many things into one problem as possible, as many different ideas into one problem. What idea is this talking about? You said no clue, yes? No. Oh. Yeah. This is about one of those existence theorems. Intermediate value theorem, mean value theorem. Intermediate value theorem is the one that we used if we have a function and I want to guarantee that function has a specific y value. Mean value theorem is what I use if I have a function and want to guarantee the derivative of that function has a specific value. Which one is this? Intermediate. We have our velocity. I want to guarantee a specific velocity value. Okay. Well, before we use this, we've got to establish our conditions for this. There's one condition for intermediate value theorem. Good. Do we know that our velocity is continuous? Did I say the velocity is continuous? What did I say? We've been through this so many times. You've got to use that connection. Because v sub q of t is differentiable, that implies v sub q of t is continuous. So we're going to start with that. Because v sub q of t is differentiable. And since I just said differentiable, that implies differentiable everywhere rather than over an interval. You could focus on the interval from 0 to 5 if you wanted. I'm not going to bother. That implies v sub q of t is continuous. Since v sub q of 0 equals 0, and v sub q of 5 equals negative 0.7. That was not right. I shouldn't just be doing this blindly. Let me try that again. You realize why that's not going to work. Doesn't include 1. Okay, so, but I feel like I can still do this problem. What was that? I couldn't hear the beginning of that. Okay, and? That would work. We need to choose a subinterval so that 1 is in between the velocities we see. I see so many different options here. I could do 2.7 to 3.5, 1.5 to 3.5. Since you said 0 to 1.5, let's go with that. V sub q of 0 equals 0. V sub q of 1.5 equals 8.2. And that's usually a thing you're going to do with intermediate value theorem. Your whole interval won't work, so choose a subinterval. Do you want me to keep going, or do you think you can come up with the rest of your language? How about you take a moment, try. If you don't feel like trying, just sit and wait, and I'll start getting my stuff up in a moment. Make sure you're referring to the intermediate value theorem by name. So by the intermediate value theorem, v sub q of t must equal all values between 0 and 8.2. Specifically, there is a time t such that v sub q of t equals 1. One other comment. I've noticed on cumulative reviews, when you use intermediate value theorem, some people might say, well, f of 0 is 0, f of 1.5 equals 8. You've got to refer to the function in the problem. Otherwise, they kind of interpret that as you just spitting back a like theorem that you know, not applying it to your specific problem, and wouldn't give full credit. I also then won't give full credit for that thing. Make sure you're just talking about the function given in the problem. Well, now, letter I. Is there a time when the acceleration is negative 9.625? Acceleration is the derivative of velocity, so this is mean value theorem. We're going to first establish our two requirements of that. For mean value theorem to work, your velocity must be continuous and differentiable. I knew it was differentiable. Again, I'm going to make that connection between it being continuous. Let's just start with that. Let's say since v sub q of t is differentiable and therefore continuous. I'm just going to launch right into the mean value theorem and hope that the formula works out the right way. If it doesn't, I'll say, well, slope guaranteed was 2. I'm trying to guarantee a slope of this. No, I can't guarantee it. Unlike the intermediate value theorem, I've almost never seen them need you to use a sub-interval of the interval provided. So let's just take this and hope for the best and see what happens. And again, I'll adjust if I need to. We're going to say by the mean value theorem, there exists a t such that a sub q of t equals, since the mean value theorem really is about derivatives, I should probably then go and say v prime sub q of t equals, and looking at the interval I was told to focus on, I'm going to say v sub q of 3.5 minus v sub q of 2.7 over 3.5 minus 2.7. Finish the calculation there. And please don't just assume, oh, it's got to be this thing over here. That was an issue on that last test with the, assuming the L'Hopital's rule thing was just going to be 0, so we can go actually show the numbers, actually work through the calculation. Let's make sure we do actually get that number. Is it the number I wanted? Oh, good. The question of this problem isn't so much about what is that number. We know what the number would probably better end up being. It's, can you go through the justification? I know somewhere my acceleration is that. Do I know somewhere the acceleration is negative 10? It's probably negative 10 somewhere, but I can't guarantee that. I can guarantee this one. Okay, how about you go do letter J? Speed of particle q at time 3.5. What is speed? V sub q of 3.5 equals negative 2.4. So why didn't I just ask for velocity? There is a difference. Aha. Speed is velocity without a direction. So if I want the speed, I really need to do the absolute value of that problem. I'm going to do the absolute value of negative 2.4. My speed is not 2.4. My speed is negative 2.4. No, sorry. My speed is not negative 2.4. My speed is positive 2.4. Questions there? We got 2 more parts. I think we're going to get through all of them. Next page. Find the times between 0 and 5 when the speed of particle p is 2. V sub p of t equals 2. What's wrong with that? V sub p. Okay, I'm dealing with speed. So I'm really dealing with what is the absolute value of that thing equal to 2. There are 2 ways you can do this. You can go to the calculator, put absolute value bars around your function and set it equal to 2, but I think the better way is what you just said. Why don't we say v sub p of t equals 2, or v sub p of t equals negative 2. And this was on a question the last couple of years, and a lot of people just set it equal to 2 and missed a whole bunch of the answers. See what you can do some solving by graphing. And I think you should just add 2 horizontal lines into your list of values. Please make sure you set your x values to between 0 and 5. Otherwise, you're going to get additional things probably that we're not going to care about. I think there are going to be 3 answers here. One where the velocity is 2, and 2 answers where the velocity is negative 2. The time when I had that positive 2 velocity was 1.200. How about the negative ones? Perfect. 2.202. Last one more time. 3.291. Good. Don't think speed is velocity. Speed is absolute value of velocity. We're getting additional answers because of that. I have one last problem we're going to deal with. Over the time interval between 0 and 5, when is particle p the furthest away from the origin, which is x equals 0? Origin doesn't mean the starting position, but truly the origin on the x-axis. Justify your answer. What am I trying to do here?
I know you're using candidates.
Okay, there's going to be candidates test involved. Of what? Yeah, the absolute maximum and minimum position of particle P. Now, what was that? Yes, because we're looking for a position, not a displacement. Also, why are we doing the absolute maximum and the absolute minimum position? I just want to know when it's the furthest away. You're right, it should be both. Zia. What's further away from the origin, a position of 4 or a position of negative 6? Negative 6. That's why I need to deal with both of them. And then I'm just going to sort of look at the absolute value of my answer and go from there. So several ideas here. First, we're going to find the absolute maximum and minimum position of particle P. You know what? How about I make a formula for the position of particle P? I'm going to say x, could be s, could be any letter, x sub p of t equals. You already answered that, but I'm going to ask it again. Do we care about the starting position of negative 2? Yes, that does affect your ending position, so I'm going to say negative 2. If I want to do this in general, I think it's the integral from 0 to t of v sub p of x, t, whatever. I'm going to use bad notation, just call it t. That is my position. You need your critical values of position. You need to find where x prime sub p of t equals 0. What's the formula for x prime sub p of t? Just v, don't forget the sub p part, but v sub p of t. You need to then explicitly show that equals 0. I've still been catching people on cumulative reviews with these things. Go find those critical values. And because I'm eventually looking for position and we're going to have to plug those in, give me more than 3 decimal places. While you're doing this, I'm going to pass out the homework, a couple particle motion things. And they're fairly recent problems. So unlike other times I've commented, oh, this is a little dated. No, this is the way they're going to ask things this year, probably. Yep. In addition, you also have the exam 11 through 16, a couple more multiple choice things, and a cumulative review if you have not already taken care of that. Yep. In 2021, 2023, 2019. These are all the recent. I think when you solve by graphing, there should be 2 times. Like maybe 1.5707963. And then maybe 4.7123889. Maybe. Okay. That's just the start. Then we do a whole candidates test thing. We're learning things. We're learning things. We're always learning things in here. 0, 1.5707963, 4.7123889, 5. I know my starting position was negative 2. We're running out of time, but you're going to do those integrals. V sub q of t. I think I'm just going to give you some numbers because I've got like 30 seconds. 389 v sub q of t equals 0.1. I think I already did this one, the 5 one from a previous problem. Looks to me like my furthest position is that 4.793, but actually I guess I didn't care about that. I cared about when that happens, so we'll say at t is about 1.5708 or something like that.